6 million people felt the ground move beneath them on Friday morning. Buildings swaying as far away as Mexico City, families evacuating into courtyards as the shaking grew from a gentle roll into something violent enough to topple objects and send people running for open ground. A magnitude 7.3 earthquake had just torn through the seafloor off the southern Pacific coast of Mexico, and within minutes, a question was already spreading almost as fast as the seismic waves themselves, across social media, across news broadcasts, across dinner tables in San Diego and Los Angeles and San Francisco. Could this reach us? Could a quake this powerful, happening in Mexico, somehow set off the fault system that runs directly beneath California? The one scientists have been warning for decades is overdue for something catastrophic. The answer, according to the people who actually study this for a living, is more layered and more interesting than a simple yes or no. And understanding it means understanding exactly how earthquakes talk to each other across vast distances and where the real danger actually lives. Let's start with exactly what happened, because the specifics matter enormously here. The earthquake struck early Friday morning at 6:48 local time, with its epicenter located about 30 miles southwest of a town called Aquiles Cerdán, along Mexico's southern Pacific coastline near the border with Guatemala in the coastal state of Chiapas. According to the United States Geological Survey, the quake occurred at a depth of roughly 9 miles beneath the seafloor, a relatively shallow depth that tends to produce more intense shaking at the surface compared to deeper quakes of the same magnitude. It was preceded by a smaller foreshock further out in the ocean, and followed by a series of aftershocks, at least 10 of them ranging between magnitude 4.9 and 6.0, continuing to rattle the region in the hours afterward. The shaking was powerful enough to be felt not just across southern Mexico, but into Guatemala and El Salvador as well, with the United States Geological Survey estimating that approximately 6 million people experienced moderate to strong shaking as a direct result. In the border town of Tapachula, residents described the tremor beginning mildly before gradually intensifying to the point where people evacuated buildings and gathered in open courtyards, uncertain how severe it might become. A tsunami warning was issued in the immediate aftermath, a standard precaution following any major offshore earthquake. Coastal areas and towns like Suchiate were actively monitored for risk. In terms of immediate impact, the news out of Mexico in the hours following the quake was, relatively speaking, reassuring. Mexican President Claudia Sheinbaum stated that preliminary reports showed no significant damage, and the United States Geological Survey estimated that economic losses from the event would likely amount to less than 1% of Mexico's total gross domestic product, a relatively contained figure for an earthquake of this magnitude. That said, the Geological Survey's own hazard modeling flagged that significant damage remained likely in the immediate region, and that some fatalities were possible, particularly given that mud wall and adobe block construction, common in parts of this region, is especially vulnerable to strong shaking, and that liquefaction, a process where saturated soil temporarily loses its structural strength during intense shaking, was estimated to be severe in some areas. This wasn't an isolated freak event either. The Geological Survey specifically noted that this stretch of coastline has a well-documented history of moderate to large earthquakes, and that Friday's quake was actually the 51st earthquake of magnitude 7 or greater to strike Central America since 1950. In other words, this is one of the most seismically active regions on the entire planet, sitting along a section of the Pacific Ring of Fire, where the Cocos Plate is constantly grinding beneath the North American Plate, a process called subduction that generates exactly this kind of powerful, shallow earthquake activity on a fairly regular basis. So, now to the actual question, driving so much of the public conversation since Friday morning. Given how powerful this earthquake was, and given that California sits along its own famously dangerous fault system, is there any realistic mechanism by which a quake in southern Mexico could set off a major earthquake in California? To answer that properly, you first need to understand two fundamentally different ways that earthquakes can influence other earthquakes, because conflating them is where a lot of public confusion and unnecessary panic tends to come from. The first mechanism is called dynamic triggering, and it's the one most relevant to understanding what a Mexico quake can and cannot do to California specifically. When a major earthquake occurs anywhere on Earth, it generates seismic waves that don't just shake the immediate area around the epicenter. Those waves actually propagate outward through the entire planet, traveling enormous distances, weakening as they go, but still carrying enough energy in some cases to nudge fault systems thousands of miles away that happen to already be sitting close to their own breaking point. A seismologist at the University of California, Riverside, explained this exact mechanism in the aftermath of a previous pair of major Mexican earthquakes, noting that when a quake occurs roughly 1,300 miles away from Southern California, there's no direct physical impact on local faults in the sense of shared stress or connected fault line. But the seismic waves generated by that distant large earthquake do still travel through the region and shake the ground here, and that shaking can, in some cases, trigger smaller earthquakes on faults that were already primed and ready to slip. The key word there, emphasized repeatedly by researchers who study this phenomenon, is smaller. Dynamic triggering from a distant earthquake tends to produce minor seismic events, not major, damaging ones, because the energy that actually reaches a fault system over that kind of distance has been substantially diminished by the time it arrives. Friday's Chiapas earthquake occurred well over 2,000 miles from California, an even greater distance than the roughly 1,300-mile example researchers have previously studied, which means any dynamic triggering effect on California faults from this specific event would be expected to be minimal at most, and almost certainly wouldn't manifest as anything beyond, at most, a very minor, likely imperceptible seismic nudge. The second, and considerably more significant mechanism, is called direct stress transfer. And this is where geographic proximity becomes absolutely critical to the entire conversation. When an earthquake ruptures a fault, it doesn't just release stress along that specific fault line, it also physically redistributes stress to neighboring faults and fault segments in the surrounding crust, sometimes increasing the pressure on nearby faults enough to measurably raise the probability of a subsequent earthquake there. This mechanism, unlike dynamic triggering, generally only operates over much shorter distances, typically within tens to a couple hundred miles of the original quake, because it depends on the physical, mechanical redistribution of stress through connected or nearby sections of the Earth's crust, rather than on seismic waves traveling freely through the planet. This is precisely the mechanism at work in previous, well-documented cases involving earthquakes much closer to the California border than Friday's event. Following a major magnitude 7.2 earthquake in Baja California, Mexico, researchers specifically identified increased stress on two nearby fault systems that extend across the border into Southern California, the Elsinore Fault and the San Jacinto Fault. In the following months, thousands of aftershocks continued rattling the border region, and a subsequent magnitude 5.4 quake struck the San Jacinto Fault zone itself, an event geophysicists directly attributed to that increased stress transferred from the earlier Baja earthquake. A NASA Jet Propulsion Laboratory geophysicist involved in that research noted plainly that scientists had expected increased earthquake probability specifically on the Elsinore and San Jacinto faults following that Baja event, precisely because of how close those fault systems sit to the original earthquake's location. Interestingly, that same research found the Baja earthquake actually appeared to relieve stress on the San Andreas Fault itself, slightly reducing rather than increasing the likelihood of a major quake along that specific fault line. A reminder that stress transfer between fault systems doesn't always move in the direction people might intuitively assume. The critical distinction, then, comes down almost entirely to distance. Earthquakes in Baja California, sitting just across the border from Southern California and sharing the same broader tectonic boundary system, can and have demonstrably increased stress on connected fault lines extending into the United States. Southern California Earthquake Center researchers have explained this connection in fairly direct terms, describing how, on the scale of the entire planet, the plate boundary between the Pacific Plate and the North American Plate functions essentially as one continuous zone, running from Southern California down through Baja California and beyond, even though it doesn't form a single tidy fault line, but rather a complex series of blocks sliding past each other. Friday's earthquake, however, struck near the Chiapas coast, close to the Guatemala border, thousands of miles south of that specific Baja California and Southern California connection point, operating along an entirely different section of plate boundary involving the subduction of the Cocos Plate, rather than the strike-slip motion that characterizes the San Andreas system further north. In practical terms, this means Friday's quake occurred far outside the geographic range where direct stress transfer to California's fault systems would be considered scientifically plausible. None of this means Southern California's earthquake risk is anything other than genuinely serious, and it's worth being clear about that, because the reassurance regarding this specific event shouldn't be mistaken for reassurance about the region's overall seismic hazard. Just last month, in June of this year, researchers published findings indicating that the southern portion of the San Andreas Fault, along with the adjacent San Jacinto Fault, sit under their highest stress levels recorded in 1,000 years. At a junction, researchers have described as an earthquake gate, a critical point that could determine whether a future major quake stays contained to a single fault or cascades across both simultaneously, spreading damage from north of Los Angeles through San Bernardino, Riverside, and the Coachella Valley all at once. The lead researcher behind that study was careful to frame the message not as one demanding panic, but one demanding urgency, urging city managers and emergency planners to treat a joint rupture across both fault systems as a realistic planning scenario rather than a remote, worst-case hypothetical. Separately, geological research examining sediment cores from both the Cascadia subduction zone in the Pacific Northwest and the northern San Andreas Fault has identified evidence of synchronized earthquake activity between those two zones going back roughly 3,000 years, suggesting that a major rupture in one system has, historically, sometimes triggered a major rupture in the other, where the two zones meet near Cape Mendocino in Northern California. United States Geological Survey seismologists have separately estimated a 7% chance of a magnitude 8 earthquake striking California within the next 30 years, and have noted that Southern California specifically appears to be, in the words of one researcher, locked and loaded with stress that is built up over time and could, once it begins releasing, continue unleashing destructive earthquakes for years once that process starts. So where does all of this leave the actual question people have been asking since Friday morning? The honest, evidence-based answer is this. Friday's magnitude, 7.3 earthquake off the coast of Chiapas, Mexico, occurring more than 2,000 miles from California's major fault systems, does not pose a meaningful direct risk of triggering a significant earthquake in California. The distance involved is simply too great for the kind of direct stress transfer mechanism that has, in past cases, genuinely elevated earthquake risk on California, faults following closer Mexican earthquakes, specifically those originating in Baja California. Some extremely minor dynamic triggering effect, in the form of imperceptible seismic nudges to already stressed fault segments, remains theoretically possible, given how far seismic waves can travel through the Earth. But researchers who study this exact phenomenon are consistent in describing such effects when they occur at this kind of distance as minor and not comparable to a genuine trigger for a major damaging earthquake. What Friday's earthquake does represent, alongside the genuine tragedy and disruption it caused for millions of people across southern Mexico, Guatemala, and El Salvador, is a vivid, immediate reminder of a hazard that California faces entirely on its own terms, driven by its own fault systems, its own accumulated centuries of tectonic stress, and its own well-documented, currently elevated risk profile, one that exists regardless of what happens along a completely separate stretch of the Pacific Ring of Fire 2,000 miles to the south. Understanding that distinction actually matters quite a bit, beyond simply satisfying curiosity about this particular news cycle. It would be genuinely reassuring, in a misleading way, to treat California's earthquake risk as something primarily driven by distant, occasional trigger events happening elsewhere in the hemisphere, because that framing implies the risk is somehow external, sporadic, tied to headline-grabbing events rather than an ever-present condition. The far less comfortable truth, according to the researchers actually studying California's fault systems directly, is that the risk sits locally, persistently, and is actively building right now, independent of what happens in Mexico, Guatemala, or anywhere else along the broader Ring of Fire. The San Andreas and San Jacinto fault junction, sitting under its highest stress levels in 1,000 years, isn't a reaction to Friday's Chiapas earthquake. It's the product of centuries of steady, ongoing tectonic pressure building directly beneath Southern California itself, a process that continues whether or not a major earthquake happens to make international headlines somewhere else in the world on any given week. For the millions of people across southern Mexico who experienced Friday's earthquake directly, the immediate concern remains assessing damage, supporting recovery, and preparing for continued aftershocks in the days and weeks ahead, a process aided somewhat by the encouraging preliminary reports of limited severe damage and no immediately confirmed fatalities as of the most recent updates. For people in California wondering whether this specific distant event changes their own personal earthquake risk in any meaningful way, the clear, research-backed answer from seismologists is no, not directly, not from this particular quake, given its considerable distance from California's fault systems and the well-established science distinguishing between minor, wave-driven dynamic triggering and the much more significant, proximity-dependent process of direct stress transfer between connected fault systems. What Friday's earthquake should prompt more usefully than anxiety about an unlikely chain reaction stretching across 2,000 miles is renewed attention to California's own independent, well-documented, and currently quite serious earthquake risk, one that exists on its own terms, driven by its own geology, and that deserves ongoing preparation, regardless of what happens anywhere else on the Ring of Fire, in any given week or month.